Hello, good afternoon, all. Hope you had a nice break in between. So, the morning session was pretty packed, and now welcome back in this afternoon session with tutorial 6. We have experts Sagar and Chirag from Hewlett Packard Enterprise, and there'll be an exciting tutorial. The title says the log and event analysis using ELK stack. Think without wasting further time, so I think let's hand it over to the tutorial organizers. The floor is all yours, Sagar and Chirag. And in between, we will collect the questions using the Q&A button and the chat window. And then probably towards the end of the session, we will have some interactive sessions with the audiences and all. And then we'll see. Over to you, Chirag and Sagar, please.
Okay, thanks, Jeremy.
Yeah.
So I'll share my screen quickly. So I hope it's visible. So we'll wait for a couple of seconds before we start. Okay, I think we'll get started. So this is a tutorial on log and event analysis using Extract. So this is me and my teammates, Rohini, Sagar, and myself, Chirag. So we'll get started with first a brief overview on what ELK is all about. So it's basically a collection of three open source products. We have Elasticsearch for E, L for Logstash, K for Cabana. So all the three components, we would go into certain details in upcoming slides and what all of them represent and how they would be useful to us in any kind of monitoring or management of our systems. So this is the architecture slide for how Elasticsearch has helped us in our use case. So I would first talk about the use case, what it is all about. Then I'll get back to this architectural diagram later. Uh, so for our use case, we have focused on certain alerts which are generated from the storage systems that are available with HP customers. So we receive around 15 to 20 million alerts per day from around 20 to 30K systems. And the cases or the customer cases generating out of them is quite less. So we needed a mechanism to understand what all alert patterns we are getting, how we can reduce them to reduce the load on our backend so that we can create the customer cases optimally and we don't need to manage so many alerts on our system which are redundant and unnecessary. So regarding this use case, Sagar will talk about more in detail and will share certain results, how ELK proved useful to us for this. So before moving on, going on to the architecture back, I'll present everything about what Elasticsearch is and how it has proved useful to us. Okay, so ELK Stack is basically a log management and monitoring tool. So with the current modern day software solutions or modern day services that we deploy and the infrastructure that they are deployed on, they need constant monitoring and management. So we need to constantly check the logs for performance as well as to check the health of the services. So LStack proves quite useful in those terms. It helps us to analyze those logs and check if our services are working fine. So with the current modern day distributed infrastructure and quite scalable, and this current day infrastructure proves to be quite noisy and dynamic. So we have to have some sort of management around this, and ELK proves quite useful in that. Okay, so ELK has three major components. We do have Logstash, we do have Elasticsearch, and we do have Kibana as a part of it. And so we'll start with the first part of the pipeline, that is Logstash. And then we'll move on to the further parts and we'll discuss about them in detail as well. how the data is flowing from one end to other end. Okay. So the first part, that is Logstash. So I'll talk about Logstash. What Logstash basically is. Uh, it's a data collection or a data processing tool. You can accept data from various sources. Uh, the inputs and the outputs could be varying. The After that data is accepted from the source, those are filtered, transformations are done, mutations are done, and any kind of parsing or enriching the data can be done, and then the data is forwarded to one of the output targets. Okay, so now the input and the output sources could vary. The input sources majorly consist of, it could be a read from standard input, it could be a read from file. Those file formats could be anything CSV, XML. It could be read from any streaming service like Kafka, or it could be read from any of the queues like RabbitMQ, Redis. So any Logstash supports wide variety of input sources. So any of those could be used, and then once the data is enriched and moved on further, we do store the output, we do export the output in one of the output targets. Again, the output targets could be again a file, it could be standard output for debugging purposes, it could be Elasticsearch itself, or it could be various other sources as well, which could be presented to Logstash. So here majorly, since we are talking about ELK stack, our output target would be Elasticsearch for Logstash. Okay, I'll talk about Elasticsearch now. So Elasticsearch is mostly a NoSQL DB. So it offers a faster search engine. So it's built over top of Lucene. So what Lucene does, it indexes your documentation or whatever data you are feeding to Elasticsearch, and those indexing of individual data points result into better performance of your search results. We'll talk about all the scaling and sharding in later slides about Elasticsearch. And once the Elasticsearch has the data, has your indexes ready, we present it to our Kibana layer. Kibana acts as a visualization tool that works on top of our Elasticsearch instance. It can be used as a data exploration tool, and you could present reports of the data patterns you have observed on Elasticsearch. So all the actionable insights that we could get from Kibana, we would get it on the data we have. So now let's discuss all of these components, these three components in detail. Okay. So the Logstash is the first part of our stack pipeline. So what Logstash does, it's again, as I've told before, it's a data processing pipeline. So whatever data you insert, it could manage those events and logs. It would parse the data, it can enrich the data, it can do all the kinds of transformations using the filter plugins, which we'll discuss about in later slide. And then at the end, we would store the data in one of these output targets. For our ELK stack, it would be Elasticsearch. Okay. So next we have the architecture slide. So this is how the architecture pipeline of Logstash looks like. You have an input data source. You can apply various filter plugins on it, and once those filter plugins do their job of transformation, mutation, processing, enriching the data, it could be written to output location. Okay, moving on. So the second part of this pipeline, that is the filter plugin. So Logstash offers various kinds of filter plugins. So we have listed down few of the filter plugins here, though there are many and could be used as per our use cases. So I would briefly go over this filter plugins, and we have incorporated some of these plugins in our pipeline as well. So the first one is the grok filter. So what you can achieve using grok filter is you can parse any unstructured data. So any unstructured data you receive, So that can be parsed into fields. So some of the Apache, for example, some of the Apache weblogs, those have some regex patterns. So those can be splitted accordingly and splitted into different fields and feed it into the Elasticsearch. Then we have date plugin. So sometimes for certain fields, we can parse our date fields, and we could store it as a timestamp for our Logstash events that we have been receiving. So those can act as a tag to our events that we have been receiving. So again, I'll show the example of how we can use this filter. Then we have CSV filter, straightforward as it is. You can parse the CSV file to get the resulting fields. Then we have aggregate. In certain scenarios, you would need to aggregate multiple events based on a common condition. So that's where your aggregate clause can be used. And the next one is Elasticsearch. Now, Elasticsearch we have used in our pipeline as well. So what happens is uh, there can be a pre-existing indices in our Elasticsearch database. So when I say indices, uh, it could be compared to the table in relational DB context. So the indices, we have the pre-existing data, and while processing our current pipeline, when we want to kind of join those two data sets, so that's where the Elasticsearch filter plugin would prove useful. When you want to connect to the Elasticsearch and fetch any pre-existing data. So this is one of the use cases of Elasticsearch filter plugin. Okay, then we have range. Range filter plugin could be used to filter out the data points which don't lie in a particular range. Then split, as the name suggests, it could be used to split the data. And then at the last, we have two important XML and JSON. So as the name suggests, these two are used to separately filter out your XML, parse your XML and JSON files into corresponding fields. So these are file-specific filter plugins. So again, there are various others like mutate, rename, transform. So those can be used to properly parse your data. Okay. So this is a simple Logstash pipeline. So we do have the input filter. The input plugin, it reads the data from our file. So here it's reading a data from a CSV file. Its starting position is the beginning. And what it does, it reads the data using the file input plugin, and it redirects the data to the filter plugin. So on the right side, if we see, there is a filter plugin. Now what this filter plugin uses, it uses a CSV one. So here we directly need to map our incoming CSV data to this particular columns. So we have listed down the columns. And in addition to that, we have specified a feature called skip empty columns. So this will be certain features specific to a filter plugin. So this skip empty columns is specific to CSV plugin. Similarly, we can find the features for other plugins as well. So this is one of the filter plugin, and once we have the data in these columns, we redirect it to the output plugin. And what we are doing here in the output plugin, we are writing it to Elasticsearch. So we have connected to one of the host, Elasticsearch host, and we are writing it to a index, or you can refer to as table in NoSQL context, hostcur data. So we are writing the data to hostcur data. So this is how the normal flow of Logstash looks like. Okay, so here in the previous slide, we talked about reading from CSV. So the next one we have is reading from Kafka topic. So in the previous slides, I mentioned that the input source could be anything. It could be a CSV, Kafka, it could be any RabbitMQ, Redis queues, or it could be a standard input. So here we are reading from Kafka topic. So specific to a source, you would have to specify the authentication, the connection configurations of where you want to read it from. So specific to Kafka here, we have specified the bootstrap servers. We have specified the topic, Kafka topic we'll be reading from, the consumer group. And here in codec, we have specified the what would be your input type look like. So here, since in our use case, we have been receiving JSON inputs, we have specified the codec type as JSON. Okay, moving forward, on the right side, we could see several filters being used. So once the messages or the events are fetched from the Kafka topic, they pass through these filters. So first one we have is the date filter. So what the date filter does is uh, it uh, it will parse your date fields and extract the date fields to tag your events. So we have extracted two fields, alarm date and alarm date time. So this will tag our events and mark it when they have occurred. So how do we get these two fields? We get it from the alert timestamp OCC field. So once we have these two fields, we tag mark it, and then we pass our data further to another filter, that is Elasticsearch. So in this Elasticsearch filter, what we are doing, we are trying to connect to a pre-existing index. We are trying to query a pre-existing index in Elasticsearch, and based on the join condition, we are trying to fetch the columns. So here, you could specify the query template or the query directly, and what it would do, it would fetch all the columns based on the join condition. So here we have fetched three columns: claim tag, cluster ID, node ID. And once we move forward, we could apply any sort of mutations on it. So it could be renaming any of the field, it could be splitting a field, it could be adding a new field. So all those transformations could be done, and the resultant could be passed on to the output plugin. So here we are writing the output again to the Elasticsearch instance. We do have certain authentication configuration specified. And the last two lines, that are the ILM rollover alias and policy, those I would explain in detail when we go over to the Cabana portal. So what these are basically when your indices get over a certain size constraint and certain time limit constraint of how old they are. So we need to delete certain data. So this rollover policy could be applied in that case. Okay, and along with that, we have specified a std out plugin as well. So this there could be multiple plugins. You could write it to Elasticsearch, and you could print it on the standard output as well. So that's what we have been doing here. We are printing it on the standard output. Okay, moving on. We'll go to the next component, that is Elasticsearch. So Elasticsearch, as I said, is a RESTful-based distributed search engine. It's built on top of Apache Lucene. And what Lucene does, it indexes your data so that you have a faster search performances. And Elasticsearch basically operates on, it stores the data in form of schema-less JSON docs. So all the data would be schema-less, and you would store the information in form of documents. And it's capable of scaling to hundreds of servers and a huge amount of data. And the thing to focus on is that we would be referring to in further slides as well. There's a slight comparison between relational DB and what Elasticsearch terms are. So in relational DB, when you call table, you would refer to it as index in Elasticsearch. And row in relational DB would refer to a document in Elasticsearch. And let's focus on one more thing, that is your shard. So we would talk about more about sharding and scaling and how that is done in Elasticsearch context. But shard, you can basically understand, it's a basic unit of your index. So one index would consist of many shards, and that would be stored across the Elasticsearch cluster. So this is a basic slide comparison between the SQL DB and NoSQL DB. Okay. So in terms of communicating to Elasticsearch, we would do it over HTTP. Uh, we would call the REST APIs that have been given by Elasticsearch. So for anything, for selecting the data, for searching the data, for writing anything to Elasticsearch, we would do it over the HTTP using this curl commands. So here, as we can see, we have had a basic query which searches for two texts, New York City or Big Apple. So that's what our query is, and it would look for this particular data documents in Elasticsearch index. So here we haven't specified any particular index, so it would look through all the indices, but we could always specify any particular index if we want to look in that. Moving on. Okay. As I mentioned about the cluster sharding and scaling, so the data in Elasticsearch, it's stored in the form of shards. And what shards is it's the basic unit of your index. So index is just like a table. It's a basic unit of your index. So as in when we scale our cluster, we add more nodes to it. The data would be distributed across all the available nodes. And the query load would be rebalanced. So if you add one more node to it, now you have 4 nodes to serve your query load. So in the Elasticsearch cluster here, we do have 3 nodes. And for in total, we have 6 shards. So those 6 shards have, each one of them have a replica shard. So what the data would be stored in the form of shards, and there are 2 type of shards that are present in Elasticsearch cluster. One would be the primary shard, and other would be the replica shard. So the replica shard would be the backup of your primary shard. And since it offers the backup of your primary shard, it would never be present on the same node. So here we can see that the shard 0, which is present on node 1, the replica of that would be present on node 2. And similarly for other shards as well. So what happens by distributing all the documents in your index across all the shards, and by distributing all the shards across all your nodes, Elasticsearch will provide redundancy in your data. And other than that, there will be a query load distribution as well. So any kind of hardware failure would be it can be safe with this particular distribution from any kind of hardware failure. Excuse me. Okay, moving on. So the last part to our pipeline is Kibana. So Kibana is a data visualization and exploration tool that we have. So it's built, it basically acts as an interface to your Elasticsearch data. So any kind of search, view, and interaction you could do with your Elasticsearch data using Cabana. You could execute all kind of queries. And in this later part, we would see how we can visualize the Elasticsearch indices using the available charts and maps. And these visualizations could be clubbed together to get a common dashboard, and we could present it as an insightful report to users. So the Kibana part, we would have a look at the portal separately. So this is just one snapshot of how the data would look like on the discover page of our Kibana. So this gives us the data split of all how many events we have received for last 7 days in our ELK setup. So this gives us the count of that. We would go through some of this components in detail in later part, and I would show certain visualizations. Okay, one thing which I have not covered yet is the architecture part. So here we have seen now what Logstash, Elasticsearch, and Kibana is. So now, other than these three components, other components can be added to them to fetch the data. So one is the beats. So what beats does is they are the lightweight shipping agents. So you install them on your systems, and they will ship the logs to a centralized server. So that centralized server could be Logstash, it could be buffered into Kafka, or it could be directly fed into Elasticsearch. So here in our setup, we haven't used any beats because we already had a Moose service pumping the data to our Kafka server. So we have read the data from Kafka, and then we have processed event by event. So these are certain additional components that can be added to your architecture in addition to your ELK pipeline to fetch the data. So here we have been fetching the data from Move service, and they have been getting pumped to a Kafka topic. And that Kafka topic is attached to a Logstash pipeline that does some filtering transformations, which Sagar will show in detail. And that pumps our data to Elasticsearch. And then through Elasticsearch, we have done certain visualizations on Cabana. So those visualizations I'll get back at. So now to talk more on the setup part, how do we set up the ELK stack? I would pass it on to Sagar. Sagar, you can take over.
Yeah, thanks, Chair. Uh, yeah, I'll present my screen share.
Okay.
So let me know once it is visible.
It's visible, Sagar.
It's visible, right? Yeah. As Chirag gave a overview of different components of L stack, so they are basically Elasticsearch, Logstash, and Kibana, and why it has to be used. So before jumping on to the setup and configuration, I would like to just give a use case why this stack is needed basically. So as we all know, right, applications they are getting developed at a very higher pace, and wherever you see in this modern world, everything happens through some of the other application. So we are in such a stage that everything is has been eased for everyone. So since with the increasing growth of applications, right, the logs or the events that are generated from these applications are getting tremendous. So basically earlier or down the line, like 15 20 years back, if you see, the data was very less, but now we have humongous amount of data which is not analyzed properly, or not utilized properly, or we don't get insights from that data properly. So the main thing is, since the increase in applications, right now, for example, in any company, if you go, there are a lot of applications which will be logging a lot of logs. So just to give a use case, like suppose if you don't have any proper kind of monitoring uh, established for your application, so what can be the possible scenarios that might occur is, uh, if there is a issue, if there is a issue that has happened in your system, so then the user has to, the application developer has to go through the logs, search where the issue has happened, what kind of issue has happened, and there is a downtime. So if there are issues, you need to go to the logs, you need to understand what is the issue, and then come with a fix, and then make your systems up. So definitely there rises a question that how do you solve this problem. So basically L stack, right, so this is a stack of three components which helps you in achieving this. So majorly it is used for analyzing logs in real time, but along with logs, right, you can use it for analyzing any events that you have stored from applications in your Kafka, which have been buffered in Kafka. So you can visualize those application, how it is, the pattern of that application you can visualize. So with that introduction, right, I'll get started on the setup and configuration. So basically this monitoring stack, right, L stack, is a open source project. Okay, so you need not pay anything for that. It's a open source. So all you have to do is a simple installation of ELK stack. Okay, so it can be installed on a single node as well, and as well as if your data is increasing. For example, nowadays, if you see huge companies like Google or Amazon or any big company, tech giants, they analyze huge petabytes of data. So for that, right, a single node might not be enough. There might be a lot of nodes which will be scaling, and even going forward, if the data increases, you need to scale your nodes. So that uh, thing is here. So in Elasticsearch, right, you can scale your nodes as your data increases, and that also without making your cluster down. You can just add extra additional nodes to your cluster, so without having any downtime. So with that said, right, these three are open source: Elasticsearch, Kibana, and Logstash. So as Chirag mentioned, right, so Logstash is nothing but just a processing agent. So whatever data it gets, suppose if you are getting a log entry, so you can't send that log entry directly to Elasticsearch. You need to parse it, or you need to do some transformation on that data, and then send in a proper format to the Elasticsearch for storing. And then comes Elasticsearch. So Elasticsearch is a document oriented database. So where you can store JSON events or JSON messages, a lot of other kind of document data, and you can store such huge amount of data that you can query that data with just REST APIs. Some REST APIs, if you run some REST APIs on that data, you will get the output within seconds. So no matter how huge that data is. So that is a good thing. So since this Elasticsearch, right, it is based on a Lucene search index. So it the queries that you run on Elasticsearch are very fast. Okay, and coming to Kibana. So now you have all your data. Now what you want to do with the data? You want to analyze, right? So you need some dashboard or some form of visualization where you can create your dashboards to visualize this data that you have collected from the backend systems. So for that we have a Kibana. So with these three components in stack, right, Kibana, Logstash, and Elasticsearch, there is one more component which is known as Beats. Okay, so Beats is majorly used when you want to analyze or read log files from different sources. For example, if it is a single source for example, if it is a single system that you want to analyze which is generating logs, so in that case you need not configure Bits. You can survive with Logstash as well. So you just need to specify the input plugin as cs whatever log file directory is there that you have to provide, and the log files will be read by the Logstash and then passed on to the Elasticsearch, and then finally Kibana can visualize it. But in case now you have multiple applications like you're running PostgreSQL, okay, and then you're running Oracle DB, which are generating logs. So now you want to collect logs from different sources. It's not just one source. You're collecting logs from different sources and multiple applications. So in that case, right, there is an option that you can install Logstash agent on each of the servers wherever the applications are running, but that might have a higher memory footprint because Logstash is not a lightweight application. So to overcome that problem, right, Beats was introduced. So Beats is just a plugin for aggregating data from different data streams. So what you can do is similar to Logstash only, Beats is also agent which needs to be installed on all the servers from where you want to collect the logs. So it might be your server logs, it can be the application logs, or it can be any syslog, whatever different kind of logs that you have, you can collect from that servers. So basically you need to install this Beats on those different servers, and what the overall work of this Beats is nothing. It just take the logs from the server and ship it to a Logstash. So you have multiple options. Either you can collect the logs and ship it to the Kafka for buffering if you want a very real streaming kind of analyzing, or else you can directly eliminate this Kafka or Redis altogether, and you can directly ship those logs to your Logstash. So then Logstash will try to do its transformation, parsing, and all, and then store the data in Elastic and search, and then finally from Kibana you can visualize. So with that said, right, we'll move on. So basically for this setup, right, there's some prerequisite. So I'll just go to the setup and configuration that you need to do to get started with a quick setup for analyzing your local logs. You can analyze the logs that are generated in your laptop, or run some application in your laptop and see how the logs are gathered from there, and you can analyze. So this is a very quick setup that I would like to introduce. So here, it's not that you can't install on a Windows system. You can install on Windows system because they are providing MSIs for each and every application for Beats, Logstash, Elasticsearch, and Kibana, which you can install independently and run. But the setup that I am going to mention today will be on Linux system. Okay, so basically you need a Linux system which is of Ubuntu 20.04 or 18.04, and some access to the terminal, a root user, sudo privileges, and you need to install Java. Uh, First thing is, these applications which are built, right? They are built using Java. So you need to install the developer JDK for this. So majorly you can install Java 8 or a Java 11, but specifically in some documentation it is mentioned that Logstash works properly with Java 8. So you can go ahead with installation of OpenJDK 8 on the systems, and then to install this nginx. So why you need this nginx? So basically for the Kibana dashboard, right? If you want to configure users who can access the Kibana dashboard, or give particular roles, kind of read roles or creation of dashboard roles, so those all things you can do using nginx. So basically you can configure, have a controlled access to your Kibana dashboard, so that no other user can access apart from the authorized users. So in that, if you want that, you need to install the nginx. And coming to the installation of the repository, right? So basically the whole ELK stack along with the beats, right, comes embedded in a single repository, that is elastic repository. So all you have to do is you have to install a PGP key for Elastic, a pretty good privacy key for Elastic, and then you need to install this transport HTTPS. So why this transport HTTPS is basically whatever repository you store, right? The repository definition you store in your system, that downloads will happen through over internet. So since to have a secure communication while the download, you need to have this HTTP package installed. And then finally you need to install a elastic repository to your system. So this is a repository that you so now the latest version is 7. Still we didn't have 8.x. The only latest version on elastic is 7.x. So you can download the repository link from the official documentation of Elastic Search, and have it stable repository, and add to your definition, a repository definition on your system. So basically whatever steps I'm mentioning here are for a Ubuntu system. So accordingly you can check for other system. If it is CentOS or a Fedora, you can check the different repository definition from the official sites. Moving forward, right, now we need to install each and every component. So getting started, first we'll install a Elasticsearch. So to install the Elasticsearch, since we have updated the repository, we have added the repository, we need to update the repository using this command sudo apt get update. And once it is updated, you need to install the Elasticsearch. So once Elasticsearch is installed, right, very minimal configuration just to get started. You just need to so there will be a file, a configuration file known as elasticsearch.yaml file in your etc elasticsearch. So all that you have to do is just configure these three parameters. If you're running a single node setup, there is no hassle, nothing. You just need to go to this configuration file. You need to configure your IP address or a local host, and a specific port where you want to run this Elasticsearch engine. And since this is a single node setup, discovery type you can mention as single node. So this is all that configuration that you need to do just to get started on the Elasticsearch. So once this minimal configuration is done, right, you need to start the Elasticsearch service. So with this command, right, systemctl start Elasticsearch, the service will be started. Now going forward, right, since you want all the services to be started on your system boot up, you will enable that service using this command systemctl enable. And then finally, to test whether your Elasticsearch engine is running properly or not, so you'll get a command. If your Elasticsearch engine is installed on a local host, then you'll get a command saying that you need so basically everything happens through curls. It can be a health check that you want to do on Elasticsearch, or it can be how many nodes are configured on the Elasticsearch, to check that you have to run a curl command. Or if you want to delete any data which is older than 6 months or older than 1 year, then you need to run curl API. So everything what happens on Elasticsearch, right, happens through curl APIs. So which is the best part of this beauty of this Elasticsearch. Said that, right, this is just a sample screenshot that is here, which shows that we have configured a 3 node cluster, out of which 3 nodes are data nodes, and our cluster name is Elasticsearch cluster. So moving forward to the installation of Kibana. So, as said, right, Kibana is used for visualizing the data that is stored on Elasticsearch. So, Kibana is nothing but a graphical user interface for passing and interpreting your collected log files. So, it's not that only log files you can analyze events also. So, basically, in our use case, we had a lot of events, basically a 15 million to 20 million events which are generated on daily basis, which are stored in Kafka. So, we used to analyze them. So there are a lot of different plugins that provided by Logstash where you can connect to different sources. So in said that, right, to install Kibana, you just need to. So this all for this all different tools, right? Kibana, Elasticsearch. You need not add a different repository. The main Elastic repository is more than sufficient. All these applications come under that repository only. So to install Kibana, you just need to run this command of installation. And to configure the Kibana, as said, no hassle, nothing. You just need to configure 2 or 3 parameters to get started on the Kibana. So similar to Elasticsearch, right? For Kibana also we have a configuration file, kibana.yaml file, which is in etc Kibana directory once installed. So so basically you can specify a different port, but the default port is 5601 for Kibana, and the host is localhost. So you can specify your IP address as well here. And now you want your Kibana to be connected to some source from where it will fetch the data. So since Elasticsearch is the one that we have choose from the stack, so you need to specify the address of the Elasticsearch. So basically I'm specifying a local host, since this is a local setup on port 9200. So a Kibana will get connected to this localhost 9200 and try to fetch the indices that are created there and populate the data, sorry, on Kibana dashboard. Okay. So once this minimal configuration has been done, then you're good to go with Kibana. So all that you have to do is you have to start the services and enable the services so that they start on the system boot up. So finally, since you're accessing this link, right, on 5601, so you need to open the port on this TCP port. So you should allow all the traffic to flow through. So so this command basically on ufw allow 5601 TCP will uh, allow all the traffic to flow through this port so that you can access Kibana dashboard through this port. Okay. And finally, to access the Kibana, right, you just need to go to that port localhost colon 5601, so you can access the Kibana from there. So as you see, there was a very minimal setup required for Elasticsearch as well as Kibana. And going forward, right, Logstash. So as Chirag gave a very high overview, right, in detail of what Logstash is and what are the different kind of plugins that Logstash provides, what kind of processing or what kind of transformation that you can achieve through Logstash. So basically, the installation of Logstash is also pretty much easy. From the same repository, it will be installed. So Logstash is a tool that collects data from different sources used for transforming data and manipulating data to store in Elasticsearch. So you can install Logstash using this command, apt-get install Logstash. And finally, you can start and enable Logstash using these commands: start Logstash, enable, and systemctl status to check the status. So to configure Logstash, right, there is nothing that you have to configure. All that you need is your application specific configuration file you need to create. So which I'll show in a while. So for example, if you have a Logstash file configuration file specific to your application created, uh, which means what all kind of transformations you need to do, what all kind of mutations you need to do, what all kind of filters you need to apply, what is the input source, what is the output source. So those kind of definitions will be given in this conf file. So all that you have to do is you just need to run the logstash along with this configuration file, which is the logstash executable file specified hyphen f your configuration file. So you can store this configuration file in this directory etc logstash conf.t. So as said, right, this logstash configuration file will have three components. One is input component, one is filter component, and one is output component. So input component means from where you're getting the input. Is it the log file that you're directly accessing, or is the input you're getting from the beats? So basically, what beats will do is beats will collect all the different logs, store it in some port, and from that port you need to configure so that your logstash will consume all the logs from that port, HTTP port. So basically, or is it a Kafka server that you're reading the input from? So all different kind of inputs you can explore here. And finally, once the data is read, you need to filter that data accordingly for your use cases. And finally, the filter data needs to be dumped at some place for visualization. So that is Elasticsearch. So we are configuring Elasticsearch for as a output plugin here. So moving to next thing. So install FileBit. So as I said before also, right, you can have only Logstash if you don't have multiple sources from where you need to collect logs. If it is just a single server that you need to collect, so then you can avoid this FileBit, and just with a Logstash standalone, you can collect that logs from that server. But if it is a multiple sources, then it's a better option to go with a FileBit. So FileBit is a very lightweight plugin used to collect and ship log files. It is most commonly used bits module, and one of the best feature of this FileBit major advantage is if your Logstash. So basically, you have options where you can send the data from FileBit directly to the Elasticsearch as well, or if you need to do some processing in the Logstash, you can send that FileBit data to Logstash, do some transformation, passing and processing in Logstash, and then finally send to Elasticsearch. So in that case, if you're sending your data to Logstash from FileBit, so if there is a case where you have lot of alerts or lot of messages coming in and your Logstash is overwhelmed with the data, or your Logstash is having some lag, so in that case your FileBit will automatically adjust its pace of collection of the logs. So you need not send any notification, nothing. So based on the rate at which the FileBit is giving to the Logstash, it will try to automatically understand that the Logstash is overwhelmed with lot of data, so I need to slow down. So FileBit automatically will slow down its um, shipping from server shipping of log files from server to the Logstash. So that's why most of the uh, pipelines, right, use FileBit as a shipping agent. So with that said, installation of FileBit is pretty simple. You need not have a different repository. From the same repository, you can install FileBit. And then to configure FileBit, so FileBit basically sends the data to Elasticsearch and can be configured to send data to Logstash as mentioned. So the configuration file will be residing in etc FileBit, FileBit.yaml. So there also a minimal configuration that goes in where you need, if you're sending the data directly to our Elasticsearch, you can configure the output as localhost colon 9200. Or if you want to go through a Logstash and then finally process the data and then store in Elasticsearch, then you can give this plugin like output.logstash, where you can specify the um, localhost port where you want to dump all the logs by the FileBit. And there is one more thing, like you can enable a module where your local system logs will be sent to your Logstash. So for that, right, all you have to do is you have to run sudo filebit modules enable system. So what this will do is whatever logs you have, right, it can be sys logs or whatever different logs you have in your local file system. So those will be sent over by enabling this module. And finally, you need to create an index where you want to dump this data so that the Logstash will go and pick that data. And finally, you need to enable this file bit similar to all other application. So start and enable, so you need to start and enable so that this service is started on boot. Okay, so with that said, right, coming to the overall architecture, since I have explained before also how the pipeline goes. So with beats, right, so these beats agents will be installed on each server if you see here. And for example, you have app log files, system log files, and these beats will collect these application files or your Postgres files or any different kind of applications. It will collect and then ship it to your Logstash, and in Logstash the passing will happen, and then finally it will be stored in Elasticsearch, and then the Kibana will connect to a indices in Elasticsearch and pull. So this basically happens on a pull model. So the data that is stored in Elasticsearch will be pulled by Kibana for later visualization. So Chirag will show what all kind of dashboards can be built in Kibana and how easy it is to create dashboards in Kibana. So one more. So with this said, right, I would like to show some REST API calls that can be done. So for example, so this is the Elasticsearch file. So as I showed in the PPT as well, right? So the configuration is very minimal. So this is a configuration for a clustered mode. So basically, you have to change the cluster name. You have to add the node name here, the IP address, and then finally uh, you need to set your host, what is this present server IP address, and the port on which it is going to run. 10022 we have configured, and finally the discovery seed nodes. So when you're trying to form a cluster, right, so whatever I mentioned the steps, they are for a single node. But if you want to add new nodes, so how easy it is to add new nodes, all you have to do is go to this configuration file, add additional IP addresses, so that on boot up they will try to, the master node will try to identify the cluster nodes that are been added to this cluster, and try to form a cluster or with all the newly added nodes. So basically you need to specify this discovery nodes that you are planning to have them in a cluster, and going forward you can have an initial master node. So initial master node, what it does is it manages, so these are little settings with authentication. So what the initial master node does is, so basically if you see the architecture of Elasticsearch, right? They have master nodes as well as they have slave nodes. So what the master node does is, master node is responsible to form a cluster and see who has been removed, which node has been removed from the cluster, which nodes have been newly added to the cluster, and to maintain the cluster state. Okay, and the data nodes, which are the slave nodes, basically will be having the data, which will be responsible for all the read operations, write operations, update, search, all different kind of operations. So with that said, right, there are few REST APIs that I'll run and show you. For example, if you want to see the health of this Elasticsearch. So if you see here, the status is green. It is healthy. And the cluster name is Elasticsearch cluster. And the number of nodes are 3 nodes that we have configured. And basically, as Chirag mentioned, right, the data that is stored in Elasticsearch will be stored in shards. So basically, how many active shards are here, how many primary shards are here, and relocating different parameters are here. So said this, this clearly indicates that a cluster is up and running properly since it is a green status. And with that, you can check how many nodes you have, or if you want specific information from that node, so you can run a curl query. So for everything you have a curl query, so that is a good part of Elasticsearch. So if you see here, right, this is a cluster name and this is a cluster UUID, which is common to all the 3 nodes, and we have 3 nodes configured here, which is 154, 155, and 87. So these 3 nodes are forming a Elasticsearch cluster. And similarly, if you want to check out of these three, which is the master node among these three. So for that, you have a query where you need to query the cluster state, providing a master node as a parameter. So if I run this, you can see that your master node is STRS81, which is this one, STRS81. So this is your master node. So different similar kind, so you have different kind of plugins. For example, if you want to see indices, so these are the indices that are created and ready for use in Elasticsearch. For example, this first column gives whether your status. What is the status of your indices, whether it's healthy or not. So since green indicates healthy, it is healthy. Then this is open status, whether you're sorry, whether you're able to access those indices or not. And these are the indices name. So we have so many indices, and we are utilizing this L stack for analyzing a lot of data that we receive from our systems, from our backend systems. And these are the UUID that uniquely identify these indices. And these are the primary shards. So for each indices, we have one primary shards, and this represents the replication factor. So as Chirag was mentioning, right, for each indices you have a replication factor. For example, even if one node out of your so basically, if you have a look into this Elasticsearch docs, right, so it says that Elasticsearch is fault tolerant. So what it means by fault tolerant is, even if one of your nodes out of Elasticsearch goes down, then it will not impact your entire over cluster, or it will not impact your Elasticsearch cluster. So basically, you will be able to process the logs or the events without having any impact or any downtime. So if since you can we have configured one, but you can configure it to a higher two or three replication factor. And since the data that is stored in Elasticsearch is a documented data, so this represents the number of documents that are stored in Elasticsearch for each indices. And this represents the number of documents that are deleted. So here the one document has been deleted from this index, and this represents the primary shard store, the total store, what 79 GB has been allocated, and total 79 GB of data we have for this index. And out of 79, 39 GB is of primary shard, so which will be located on your master node. So with that said, right, coming to Elastic Logstash. So basically, just to show that, right, our Logstash is running in the background. So if you see, right, the logs are still processing here. We are running this service in the background. So just not to interrupt that service, I'll just show what file we are using for running that. So as said, right, Logstash just uses a configuration file very specific to your application. So this is a file that even Chirag has gone through. So where we have an input plugin, since we are consuming all the messages from Kafka, we have a Kafka input plugin, and these are the different parameters like bootstrap server, what are the Kafka server, and which port, which is the topic from it, which it is consuming, and the consumer ID. And these are the SSL configurations. That since the Kafka cluster is authenticated cluster, so to connect to a authenticated cluster, you need some SSL security trust store configurations and all. So that is provided here. Then in filter, right, as Chirag mentioned, then whatever we are getting, you can split the date time into date separately and time separately. So you have plugins for that. And suppose if you want to gather data not only from one source, you have some data in some other source like CSV file, which has some customer information which you want to join with your data that you are receiving from Kafka. So that for that you need to pump that data as well to Elasticsearch. So here we are pumping that data, we're using a nested query. And this Chirag has went in detail, so I'll just give an overview. And similar to if you need the customer information like serial number, the customer region, country, so this is fetched from a different source and pumped into Elasticsearch for visualizations. And finally you can run a lot of mutations here. For example, we received some entries which had one as entry, but we know that having a one entry is nothing but a red which marks as red, so we are mapping it and mutating it. So there are many kind of different plugins that you get to filter out. And finally we are dumping all the data to Elasticsearch. So with that said, there is one more thing left on uh, Elasticsearch. So as we all know, right? So Elastic's stack, right, not only provides you the capability of uh, reading the log files and then analyzing the log files, it has the machine learning capability as well. So what does it mean is basically, for example, if you're collecting a lot of logs, or if you're having a lot of events, for example, in our use case, we used to receive roughly around 15 million to 20 million of alerts from our backend systems. So we were very suspicious that sometime if the storm goes to 25 or 30 million, we should be aware of that when that will happen, so that we can take preliminary actions to avoid those to avoid that. So in that case, right, there is a very good feature that is provided by LStack machine learning. So to be noted, this machine learning library or the component in LStack, right, is not free. It is it comes with a cost that you have to pay, but all other whatever I have explained till now, right, are free of cost. You can have a LStack just to analyze the logs, collect the logs, everything. But if you are going to visualize or do some predictions or forecasting, so in that case you need to pay for that. So if you see here, right, in this graph, till here you have the data. So here it will forecast the data how your patterns will go for the next few days. So it will basically tell you when can a storm occur. So from your past history, right, it will indicate you that at some point of time there might be a storm of alerts that you will get in future. So similar to a lot of arima or sarima model that people from ML background, right, uh, use for forecasting any time series data. In a similar way, here, right, some forecasting algorithms are used, which will tell you what is the alert forecast that will happen for next few days. Yeah, and the one more good thing is you can check for anomalies as well. So it's not just that you can predict the forecast. You can check for if there are any anomalies that are happening or any events that you think might be are anomaly. For example, here, right, KPI. So KPI is nothing but a key performance indicator, which most of the performance people might know. Here, right, sometimes you need to in performance you need to monitor the low ends that might hit. For example, if there is any threshold that you have configured, and if your performance is going below that threshold, then it is considered as an anomaly. So for that, right, there is a feature that this gives a severity. Here if you see, right, yellow means there is an anomaly, sorry, anomaly, but the severity of that anomaly is less. But if you see the red ones, right, there is an anomaly but the severity of that anomaly is high. So in this way, right, anomaly detection can be done, and the severity as well can be uh, uh, got to know from this feature of machine learning on LStack. So with that said, right, if you want a overview idea of this anomaly that has happened, like from which server it has happened, due to what it has happened. So if you see, right, you can hover on this and click this small check boxes. So indicating that these red are high severity anomaly. And for example, when it has happened, the severity of that, and due to which, like Nginx access source IP high count. So this is the reason due to which it has happened and from which source it has happened. So all different kind of information that you can get in advance. So these are things that come under a machine learning. And coming to our use case, why there was a necessity of LStack and why we had to use this. So as I said, right, we had a backend system which were generating huge amount of alerts, roughly around 15 to 20 million of alerts. And the use case that we have it, we used to analyze those alerts manually by specifying the offset, Kafka offset, and then we had a Python code which used to read that. Which is to which in a batch format, and after some time we had those results to visualize. So to overcome this scenario, right, and have everything in real time, all the detection or the alert storms that are happening, or the components like from which serial number or from which systems the alerts are generating high, and with what frequency they are generating, what are the chatty components, to analyze all this and come up with a decision, right. We had utilized this LStack. And as said, right, simply so it was generating like from our 20K backend system, right, we had a huge number of alerts, and we used to have a lot of cases that are getting generated very frequently. So sometimes, right, due to this huge, humongous amount of alerts, right, with a higher frequency, we were having a delayed case creation. So to overcome this, right, after having LStack analyzing a lot of alerts from different components, we got to know that we are sending alerts too frequently for a single error as well. So to avoid that, right, we tuned our systems to a greater extent, and then we had a very good results from that. So it's very crucial that you reduce these alerts on your backend system, because sometimes if you have huge alerts in your backend system, right, it might choke your backend system and might lead to a downgrade or a downtime of the systems, and which might have additional work, like to the team members who needs to handle the system, then bring them up. So a lot of things happen. So to avoid this, right, LStack has proven us very well benefit for us, for our use case, and to derive decisions from it. So moving forward, right, what LStack analyzing has helped us. So to understand the alert storms that can happen at any time, and the alert frequency, with what frequency these alerts are generated, whether they are coming from a single system, or with what frequency they are sending, what are the components. So basically, from in system there are applications installed. So from that application, from which component the errors are coming more, so that you can reduce your logging, if unnecessary logging, if it is not required. So a lot of things you can derive from this. So unique alerts, your chatty alerts, like basically which are the serial numbers which are generating huge alerts unnecessary. So a lot of things you can analyze from here. So with that said, right, we had 20K systems which were generating huge alerts, roughly around, if you see the number of systems, and if you uh, calculate this, roughly around 15 million to 20 million we had. Then after using LStack and tuning our systems, right, we reduce those alerts frequency, so that in the backend we process less number of alerts. From this huge number, we are processing only 720 now after the enhance. So since the enhanced number is too less, it is not visible here. But if you see, right, there's a huge drastic change that we have got into our systems by enhancing our deduplicator, by reducing the sliding window, the window with what frequency the alerts are sent. So this so if you see here also, right, we have reduced the alerts from chatty commands by 1 by 5 times, uh, and in all the OVSs 1 by 8x times. So this is how we have utilized LStack and enhanced our backend, enhanced our alert deduplicator, and reduce the alerts that we process in our backend. So these are just rough numbers. Like in the current dedupe, we were processing these many alerts, but with the enhanced dedupe, through the decisions that we derived from LStack, we are processing only 720 alerts from these many systems. So improvements. What improvements we done is, basically we got to know that we need to increase the time that we store these alerts in the map. And finally, the unique alerts that we have reduced is, sorry, from 20,000 to 720 alerts we have reduced. And it is, after reducing this, right, the number of frequency of alert generation, we are processing huge number of alerts at right time, with case creation in a timely manner. So there are no cases that are created in a delayed fashion, since the alerts that we have reduced in a backend to a greater extent. So with that said, right, coming to an end, what are the benefits of having LStack? Why you need to have a LStack? So first thing is, LStack is free. It is just free to get started. Any engineer, any student, or anyone who needs to analyze log from the system, or from any server, or from any application, can install this ELK component in a very hassle-free manner. It's all that just a few configurations that you need to do. And once these components are installed, you can have your all LStack up and ready for usage. There is no software licensing fees, provided if you want to do some ML stuff, then you need to have some paid version for that. And multiple hosting options. So if you have your own on-prem, for companies which they have their own on-premises servers, and also they can opt this LStack to analyze huge amount of data, or else these can be deployed on your Amazon Elasticsearch or any cloud provider as well. And the major thing is centralized logging capability. So what does this means is, whatever logs you have, right, from multiple sources, they all will be aggregated and stored in a central Elasticsearch nodes, so which can be scalable horizontally. So if the data increases, you can scale as you want. So all the logs, right, from different multiple sources will be centralized to one server from where you can visualize all those logs. And the other benefit is real time analytics. So as I said, right, earlier we used to write some code which used to run in batch, and then we used to visualize data. So to overcome that only, we wanted some real time analytics that we can derive decisions from them, and take necessary actions at a very faster pace, so that we avoid unnecessary storms in our systems, or avoid unnecessary processing of alerts in our backend systems. So one of the thing is you can analyze real time data and visualize all the data in real time. And one thing is, even the coding support, like for example, if you want to have some clients through some code, you need to connect to this Elasticsearch and all. So you have multiple programming official clients that provided by Elasticsearch as well. Roughly around 12 programming languages support clients that you can use to connect to Elasticsearch and fetch data, delete data, or do all the necessary action through REST APIs. For example, JavaScript, Go, Python, .NET, Perl, and etc. So this said, right, I would like to end my talk here with a small demo which Chirag will present with all the graphs that we have developed and how we are utilizing them to analyze. So yeah, thank you. If there are any questions, I would like to take at the end.
Okay, sorry. Thanks. I'll just start presenting.
Yeah, I'll stop. Yeah,
Okay. I hope it's visible.
yes, Chirag.
Okay. So now I'll quickly go give a walkthrough on the Kibana portal. So this is the general page of the Cabana dashboard. So on the left hand side, currently we don't see any data. So on the left hand side, we do need to select our index pattern. So now this index pattern is different from what indices we have in Elasticsearch. So this is the Kibana index pattern. So how do we create Kibana index pattern? So on the left hand side, we do see there is a management console. So once we go here, under the Cabana subheading, we do see index patterns. And in this index patterns, we could create index patterns for Cabana. So what does it symbolize? It tells you basically that it's a pool of indices that you want to visualize in Cabana. Pool of indices from Elasticsearch. So since our Cabana is connected to our Elasticsearch instance, we could create a Cabana index pattern here, and we need to create the pattern exactly as how our index in Elasticsearch looks like. So currently, we do have the indices with the sdef-alert pattern. So we do have to create the index pattern to create a pool of all these indices. So we already have this index created. So it says that there is already an index pattern created. So I'll use that to further demonstrate the visualizations. So this is the basic way to create an index pattern. And once we have created the index pattern, here we could return back to the discover page. And here, once we select our index pattern, so in the last 15 minutes, we don't have any data. So we could change this time duration and select our time window for which we want to see the data. So I would select the last 7 days. So it would take certain time to query the Elasticsearch data, and it would give the hits of how many events are present for the last 7 days. So it gives around 153 million hits grouped by individual days over a period of last 7 days. And this search bar over here is where you can type your Kibana queries that would effectively query your Elasticsearch data. So before this, on the left hand side, you could see various fields or columns that are present in our data. So you could always list them down using this add button here. And once we have this serial number and all, we could use this query window to query whatever we want in Elasticsearch, basically to filter out your data. So I would select one of the fields, and what I would do is I would give it this particular, let's say, device serial number itself. So basically, this is just a filter query to see how many hits you have for that particular field or particular device serial number in this case. So over a period of 7 days, we have around 5.5 thousands of hits. And rather than exact matches, we could always do the wildcard searches as well. So here it would look just for that serial number starting with this BL4. So all those type of queries which you generally do on your DB, all those filter conditions could be put over here, and the data could be filtered accordingly. And this would be a general visualization on the count of events that you have received. Now moving on, the next one is your visualize console. So this is where you use your Elasticsearch data to visualize. So you could create visualization, and it does offer a variety of plots, chart types. You could select any of them. There is a time series, there are pie charts, there are heat maps, horizontal bars, stacked horizontal bars. You could have a pie chart, as I told, and you could have a data table, a data representation of your data set, a table representation of your data set. So if we select, let's say, data table itself, the next it would ask is for you to specify the index pattern. So index pattern in our case, as we created before, is SDEP alert start. We want to observe these indices. So we would select this. So currently it will just display the total alerts or events received for the last week. The data, the time range could be modified here. So what you need to do is in the bucketing, you could specify any particular field and you could group your data based on that field. So if I split my, so if I create a bucket and split my rows, so it will give you an aggregation column. So you could select any specific terms, and there are various other data types on which you could sort your data into. So here in the terms, you could specify your column or field on which you want to group your data. So since we have used device serial number before as well, I'll just stick to it. And once we have the device serial number, this just gives the 5 prominent serial numbers in the last 7 days. So we'll just list out those 5 prominent serial numbers. So once I click on update, so it has grouped the data into this 5 serial numbers. So these are the 5 prominent devices from which we have received our alerts over a period of last 7 days. So such grouping can be done for all the fields present in your Elasticsearch database. And once you have created a visualization, this is a data table visualization. You could always save it and it would be present in your visualization directory. So I would return back to the visualize now. So we have already created a couple of visualizations, which I would show in the dashboard part. So let's now move on to the dashboard section, dashboard console of our Cabana. So what it does is basically when you want to pool your visualizations, you want to collect your visualizations into one common report, you use your dashboard. So you can create on dashboard and it will create a new dashboard for you. Now here it will give you a report or a space to add your existing visualizations. So you could create new and it would redirect you to the visualize page, or you could add an existing visualization already present. So once you have added that visualization, you could save it as a dashboard report. So we already have a couple of dashboards which we have created for our use case. Uh, I would just go through both of them so that to show how the dashboard would look like. So I have just kept it open for the purpose, like sake of time, so that it doesn't take time to load. So one of it is alarms on daily basis. So this is one of the dashboard reports. So here we have the data for last 2 days. So what it shows is on 5th of January, this many events or alerts were received, and on 6th of January, this many alerts were received. So it gives you a count or how many frequency of your data points for individual days. You could always customize your time window. So similarly, the next this particular bar chart, this gives you the device count for both the days on how many devices were errorsome or were causing issues for both the days. So this gives you the count of devices. So the next one is your message description. So what were the major issues that had occurred on those 2 days? So it just prints out the error messages from the logs, from the data logs that we have collected. So this just gives you the most prominent issues that have occurred on those 2 days. So again, you could customize your time window. You could filter it out for a few region or few systems or few customers of your own. So those type of filtering could be done, and it would just display that particular filter only. Again, this represents the same thing. It represents the major issues that have occurred on those 2 days. And this again gives you the devices which have had most issues on those 2 days. So it just gives you the count of those. So it's around 731 million for 7 lakh 31,000 for the first one, and the remaining follows. And again, the right side, this is one other type of chart, that is your stacked bar chart, that gives you the serial numbers along with the prominent issues in those serial numbers. So these types of visualizations, stacked visualizations, could also be done in Cabana. So this is how a dashboard report looks like. It is basically a collection of all your visualizations. So I would quickly go on to the other one as well and show certain charts there as well. So this particular I would like to focus on. So rather we could pinpoint to what component in our devices or what major services in our devices are causing issues. So these two charts basically depict that. So we have the alerts, but can we pinpoint it to certain components? Yes, we can. We can do it using these charts. So we know that this particular component is causing issues in majority of devices. So this is it visualizes that. Similarly, this can be done on any other data fields as well. You could pinpoint of what the issue could be. The next one is the word cloud. So we have received alerts, but what is the frequency distribution of those alerts? Do we have the error or the warning as majority? So this clearly tells us word cloud that error is the majority of alerts that we have received, and that's a prominent part of our data set. And these are certain similar charts to give you an idea on the data. Pie chart is another symbolization that you could do with your data. And one more thing. So the last one, which is this could be called a stacked pie chart. So what it does is in the inside, it gives you the customer account type, basically. In which particular account type we have received maximum number of alerts. And that particular account type belongs to which country. So in the inside, it gives the account type distribution, and in the outside, it gives the country distribution. So these kinds of visualizations could also be done in Cabana. Now, one thing which I have left before, I would quickly cover that. Okay. So once you go in the management console, so here you could go to Elasticsearch and see your indices. So since we have connected to Elasticsearch cluster, we could always list down all of our indices. So we told that in the initial part, I told that we have been rolling over the indices with a limit of some size, and we would delete older indices with a time constraint. So here we can see that storage size is 80 GB. So this 80 GB basically consists of your primary and as well as the replica. So though the limit is of 40 GBs on your primary data, the replica makes it double the size. So once we have reached 40 GBs of size in primary shard, we'll roll over that indice and we'll start storing in another indice. So, and with the timestamp. And what happens? The policy says that we could specify the policy that once after every 35 days of rollover, you could delete the older indices. So to preserve the data in Elasticsearch cluster. So these are the list of all the indices, and the policy could be attached to any indice. So here we can see there is a lifecycle policy attached to this index. So that is the data purge uh, lifecycle policy. So if we go to that lifecycle policy, we do see that there is a rollover every 40 GBs of data in the index, and the delete phase is activated when there are 35 days have occurred after the rollover. So these types of rollover policies you could always specify in index. It makes the querying faster since a particular index is not that much large, as well as you could always safely delete any older data. And this could be attached to your index to activate the particular policy. And so yeah, that's all I had on the Kibana part. We would be happy to take any questions now. Just a second.
Hi. I think in the Q&A there is a
Yeah,
question
sorry.
about what the Kafka output is stored.
So Rajesh, the Kafka stores the data in the form of topics. So it has its own server where it will store the data, and to consume that data, you will be assigned a consumer group, and that will keep track of that offset, and that will feed the data to Logstash.
Okay, and another question is, will you be sharing the slides? So probably not directly, right? It will be available
Yeah,
through the
I think if
conference
it's through
website.
some portal or something, we could share it definitely.
Okay. So overall, it's a good session, really hands-on, so a lot of things happening.
Correct. Thanks,
Right?
Ranjit.
So I have one typical question for you. So other than your organization, is this product available as a solution to others?
So currently, people have been using ELK as well as Splunk for their log analytics solutions. So I think people have been using Splunk mostly, but that is more kind of towards the cost parameters and more kind of licensed. But ELK has been slowly and steadily taking its place as more kind of open source. So yeah, it's readily available in the market. This solution is available, so people have been using it.
And whatever you developed at Hewlett Packard, so I think you contribute to the open source to develop the ELK framework as well.
Currently, not towards the ELK framework. So mostly we have used is existing prototypes and existing practices, but currently we haven't.
Okay, and probably for the interest of the community, if you can share the discussion board, so is there anything that people can just go and then have a further reading? Is there any discussion forum available?
Yeah,
Some
there are various discussion forums available on Elasticsearch, but mostly documentation, I would say, on Elastic is self-sufficient, and it answers a great deal of questions there. Uh, so there are links to discussion. There are itself link discussion forums there on the Elastic portal itself, on their official website. We could find it.
okay, and this is probably one of the industry standard thing available in the market. Right? So, what all other alternatives that the other users can explore actually, just to from a different
Yeah.
perspective. One is from algorithm perspective, a performance perspective. What
So
else?
one strong, I would say, not complementary, competitive to this would be Splunk, so which is widely being used. So that can be explored as performance-wise. But ELK has taken advantage more in terms of its feasibility to use various things it has given, various features it has given, and more towards the licensing part. So being on the open side, open source side, it offers you a great deal of features, but it could always be compared with Splunk that is readily available.
Right. So there is a question from Gargi Dasgupta of IBM. So is there a way to plug in custom data analysis, add correlation algos on Elastic?
Custom data and add correlation algorithms on Elastic. So correlation algorithms, we haven't explored that much, but that we could attach any existing correlation algorithms to Elastic. But because on the ML side, we haven't explored that much. But ideally, I think they have been working on it, and I'm not sure there should be a way, but not perfectly sure on that.
In the same context, there is a reference of Splunk machine learning toolkit, in which supposedly have the capability of getting others as
Correct.
a plugin, right?
So Splunk has a wider use base. As I said, ELK has been developing in that regards towards the customer base, and Splunk has already many paid features available, through which many plugins could be attached. But on the ELK side, still I would say we haven't explored much on that.
Okay, maybe so. With this, we are also at the end of the tutorial. So, if I may request that if you just close the screen share, we'll take a photo using this platform. Thank you very much, and
Thanks,
thank you on
Chiranjeev.
behalf of the organizers and the sponsors. I think so. There are several organizations who have sponsored this event. Hope that this is very meaningful to the audience and will keep the momentum. It's not just one-time activities.
Correct.
You'll be able to create the communities, interact with people. I think with this, we are towards the end of this session. So you'll have a half an hour break. We'll resume at 3 o'clock Indian time, right?
Right.
Thank you.
Thank you,
Thank you very
everyone.
much. Yeah.
Thanks, Chiranjeev.